Hey there. Today I want to do a relatively quick demo showing how you can use FlashBlade fast operations to rapidly clone Vertica Eon mode databases. So with that, let me introduce you to the environment we have. So here I have the window for my management console, and I have two different clusters available. One is the source cluster that I'll be using as the source of the clone database. And the other one is the test cluster that I'll be using to test the clones and also for DR. So I have a database up on the source cluster, and this is the database that I'll be cloning. It's essentially a VMart database that I populated with about 100 gigabytes worth of data. I also have two FlashBlades, one that is running at the source site. The other one is my destination FlashBlade, and the two are replicating between themselves. So the data that is on the source FlashBlade is being replicated to the test FlashBlade over here. What I'll be using to do most of this testing is some code that's actually available for download at code.purestorage.com. So if you go and click this database button, you will see a Vertica tile. And then if you click this repo link, you will go to a Vertica repository on Pure Storage Open Connect. And that's where the code is going to be that I'm showing off. So speaking of code, what I have here is a terminal that's connected to a bunch of different machines. I'm using Tmux. Over here in window 4, I have my management console, and I'm in this Vertica cloning code directory. And then in window 5, I have, I call VC2, that is my source cluster. In window 6, I have VC4, which is my destination cluster, and the test cluster basically. And then 7 is another window open to the management console host, where I will be running a script that's set up to slowly reload the Vertica database, which again here is a 100 gig instance of the VMart database. So with that, let's go on to the next step. Okay, so the first thing we want to do over here is start the script that will essentially, drop the existing VMart database and start reloading it slowly. And the reason I want it reloaded slowly is so that I can try all of those cloning and DR tests while the database is being populated. So this is a much more challenging test than when the database is basically sitting idle and has no updates going to it. And to do that, I'm going to be using this Ansible playbook that I have called VMart Slow Reload. And, if we take a look at that, see it has a bunch of different steps here. But essentially what it'll do is it'll drop and recreate the empty VMart database. It'll check if the VMart data exists. And if it does, at the target size or about the target size, it won't regenerate it if you don't want it to. If you do want it to be regenerated, it'll regenerate it. Then it'll load all of the different dimension tables, which are pretty static, and then create basically a parallel load script to load all of the fact tables, which are divided into 10,000 files for each one. And, it'll load each sequence and then wait a few seconds before loading the next one. Once it's done, it's just going to get the sizes of the completed database to make sure that everything is good. So that's it. That's the playbook I'm going to run right now. And to do that, I'm just going to start. Okay, so it's going to check before it drops the databases. And now it's going to go and take a look at the size of the existing VMart directory. And it says like, okay, it already holds about 100 gigs, do you want it to be regenerated? So I'm going to say no. So it's going to skip all of those steps. Now load the dimension tables, and it'll create the load script, copy it to the node, and now it starts the slow load. And if I go to my FlashBlades here, I see that there's a bunch of write activity happening on the FlashBlade hosting the database. And if I look at the other FlashBlade, it's actually holding a little bit of that data as well. It's actually the source of that data, but I don't necessarily think that that's what's going on over here. Let's take a look at the database in the management console. Okay, great. So we have a number of queries running over here. They're associated with the fact tables. A bunch of them have already succeeded. So, if we take a look at this query, it's basically just a copy statement. Now it uses a wildcard and on any node. So that's part of what, the script does. Okay, so we let this run over here. And while it's doing this slow load, let's go back to the terminal and we'll take a look at the database cloning script. So over here, one of the things that we have is the Vertica clone DB YAML playbook. And if we take a look at that, we'll see that it does a bunch of different things. So first, what it'll do is it'll run some stuff on the source database to prepare it for cloning and do some readouts. Then it's going to clone the database. It's going to flush the data collector, or actually, I guess that's optional, but it'll wait until the database is synced to the communal storage, and then on the destination, start cloning that database. And here in the cloning test, we are essentially using the same FlashBlade for both the source and the destination location, the path for the clone. Although we are going to revive the clone database on a separate cluster, that's that VC4 cluster. Anyway, you'll see what happens while this thing is running. So let me quit out of here and then kick this off here. Okay. So again, it's called Vertica DB. There's some data in there. It's going to do some tuning on the destination and, just run some of this setup. And now all of that happens very quickly. The steps that can take a while is reviving that clone database on the test cluster and then starting that database. And part of that is because it needs to check out, and find a consistent epoch. So that's part of what goes on over here. And okay, it's revived that database. Now it's going to start the database and we'll see how that goes. So while we're waiting for it to start the clone database, let's take a look. Let's see if there's any running queries. Now, these queries finish, in less than a second. So there's a good chance we won't really be able to see them. But if we, again, go back to our load, we see there's a bunch of success. If we drill into this, okay, now, like first time we checked, it was working on fact files that end with 13. Now it's working on fact files that end with 62. So it's making progress and it's continuing to slow load. Okay, so great. Now we've started that database. We've checked that the database contains data. And this is the DR or the clone database that we're looking at over here. And I'll go and review these steps once the playbook completes. So we'll see what it did. Okay, great. So If we go back here, one of the things that we'll see is that we revived the clone database at the destination, and that process took about 23 seconds. Then we were starting that clone database, and that took about 32 seconds. And after that, we just, displayed large projections that are in that database. Right now, this database is slowly reloading. So, the biggest table is the store sales fact table with about 67 million rows and 1.6 gigabytes. The store orders fact table has, 6.7 million rows with only 0.2 of a gigabyte. And that's really about it. So once that database is running, we are going to stop the clone database and then drop it. We validated that it's a valid database that we've successfully cloned. And that's about it. So, as we review the timing, what we can see is cloning the actual database took about 2 seconds. Reviving the database took about 23 seconds. Starting the clone database took about 32. And then stopping it took 13. And dropping it took about 14 seconds. So altogether, this playbook took somewhere on the order of, less than 2 minutes to run, to validate that we can clone the database and then revive it and start it to validate that the database is solid and then query the database. Cool. So that's really about it for the cloning for test and dev demo. The next one is to see what it looks like using DR and replication. One more thing that I wanted to show you. If we go to our source FlashBlade, one of the things you could see is there's this big spike in replication traffic. And if we go to this replication slide that tracks performance for replication and zoom in over here, we'll see that once we cloned the database at the source side, what happened was that clone was rapidly replicated to the destination. So here, there wasn't actually a ton of data to replicate, and it was being replicated at over 600 megabytes a second. If there was more data, it actually would have reached a higher steady state. But if we go and take a look at the destination side under replication, we see the exact same curve, but this time we're looking at writes rather than reads. Right. Cool. So that's pretty much it for the cloning demo. I really mean it this time. Okay, so in this part of the demo, I want to show off what cloning looks like in a DR scenario. So in this scenario, what's happening is we have a database running on the source side, and it is being replicated using FlashBlade object replication to another FlashBlade that is sitting at a DR site. And what we want to do is test the database at the DR site. The reason for that is we want to make sure that, the DR database can be revived. And we might also want to make clones of it at the DR side to use for other things like, additional test and dev, maybe some additional query offloading, whatever. So this is the scenario that we're looking at this time around. And to do that, we're going to use a slightly different playbook called Vertica testdr.yaml. If we look at our load situation, it's still running. When we go to our management console, and kind of refresh the data, we see that it's now up to, file 194. So it'll go up to 9999. And, that's part of that slow load loop. Okay. So it's still running. When we look at our FlashBlades, there's a bunch of activity going on. If we look at replication, we see that the data is being replicated from the source FlashBlade to the DR FlashBlade. If we look at the DR FlashBlade, we can see that it's writing the data that's being replicated. And, this is the setup. Now let's go and run that playbook. and we'll see what it looks like. So the process is very similar to what the cloning on the source side looks like. The main difference is because we're replicating, there's a certain replication lag between the source and destination. And here, what we've done is use the FlashBlade API and the Ansible modules for FlashBlade to query what that lag is. And it turns out it's about 105 seconds. So this playbook has some logic in there that says if the lag is less than some user-defined amount, which here is 900 seconds, then what we're going to do is wait for that lag to propagate from the source database to the destination database, and then we're going to clone it at the destination. So right now, we are essentially just waiting out that 105-second delay. Okay, so the lag has expired, and now it's starting to do some additional testing of the DR side. It's cloned it, and now it's trying to revive the clone database. So again, we've filled more of the database, so it probably took a little bit longer to clone, and it's probably going to take a little bit longer to revive. So we're just going to wait for that revive. And while that's happening, let's take a look at the replication. So the replication's been going steadily. These should be mirror images of each other. One is reading data and sending it. The other one is writing the data that it receives. If we look at the dashboard, this is actually easier to see on the performance side. If I zoom in on the last 5 minutes, basically these little bumps that are peaking at around 40 megabytes a second. These are the writes into the database. So Vertica is executing those copy commands, and then it's compressing the data, putting it in RUS containers, and storing it on this FlashBlade. So now, oh, wow, it's done. So let's wait for this to finish up, and then we'll go back and see what it did and how long it took. Okay, so it finished. Let's scroll back up here. So when we stopped, it was trying to revive the database, and it successfully revived it. It took about 22 seconds to revive it. Now it's going to start the database, and again, it takes a little while to validate and find a valid epoch to start the database from, and that took about 34 seconds. Then it displayed the large projections. We saw that the database grew a little bit from last time. So now it has about 278 million rows and 6.7 gigabytes worth of data stored. We output the count star for one of the tables, which was basically the store sales fact table. The reason that this didn't print out in the last demo is because I forgot to set the environment variable that defines which table to do the count star for. But, this is just a demonstration that we can access and read a table in the clone. Now it's basically stopping the clone database and dropping it, and then deleting the data associated with that clone from communal storage. So all in all, this playbook took about 3 minutes and 36 seconds to run. And if we kind of review, the thing that took longest was actually just waiting for the propagation lag to get to the other side. Now what we're doing is reviving the clone. That took 22 seconds. Starting it took 34 seconds. Stopping it took 15, and dropping it took 15 as well. So again, this is pretty much the demo. We just wanted to demonstrate this capability. Provide a little bit more context. What is happening is when we make a copy object command, like API call, to the FlashBlade, where the source and the destination objects are both in the same bucket, the FlashBlade can speed things up. We essentially do pointers copies or pointer-based copy on the backend data to create the copied object. And that takes pretty much no time at all. So what this lets you do, and it also uses up no additional space, since we are pointing to the original object, and Vertica doesn't really change ROS objects very often, especially older ones once they're merged. So what this gives you is a fast, space-efficient way of cloning even very large Vertica databases and doing that quickly. The Ansible playbooks are available as open source. They're really meant to be examples, not something to put into production, but they're available to modify and productionize in your own environments. So that's pretty much what I wanted to demonstrate today. Hope this was useful. And again, if you want to learn more, check out this repo, Pure Storage Open Connect /Vertica, which you can easily find by going to code.purestorage.com and clicking this database button to find the database related code. So thank you for watching. Take care.